So we can have some equivalent changes on the logs as well. So if I have our original expression log base A of argument x equals exponent x, okay, so just gonna clean that up a little bit here. Okay, this is what our original expression was that we defined above. So we know that this is going to be equal to exponent A here, and we can add in this extra exponent of 2 on the base and the argument, and that's going to balance off because what's happening is that exponent is being applied to both sides of that expression. Okay, so it's being balanced that way. So this can be then generalized. We can express that exponent on the base and the argument, and it doesn't change the value of the A on the other side. Okay, sorry, in this case it's not A, but it would have been the X on this side. Okay, that's my original exponent. If I want to do a change here, I've got my argument X. If I power the base here with this power 2, I can balance that off with a root on the other side. So this represents, a root on the same side, because remember that this exponent goes with that base. So if I do a change of power 2 on the base A, I need to balance that power 2 with a root on that. Okay, because again, if I write this, if I connect this back together, this A squared will have an x over 2 power applied to it to get that argument x. And these then will cancel each other out and they will undo each other. So again, there's where our balance falls. If I have this change of squared on the outside, on the argument here, that's on the argument side, so then I need to have a change on the exponent side. So up here I had the change on the exponent side there of this exponential expression. So this was a to the x equals big X. I've made a change here. I need to make a change on this side. Well, that change can also show up over here as this extra 2 on that side when I put that 2 on the argument here. And so these are equivalent expressions. Okay, so this does not change the original logarithmic expression. I can square the argument and I can times the power by 2 and it gives me an equivalent expression. We can actually see that as a balance algebraically when we move that 2. This 2 comes to the front side here and we can see that there's a divide 2, which would cancel that as well. We can have a times 2 on both sides. And again, it balances off our algebraic expression now. So there are lots of different things we can do now with exponents if we have this little bit deeper understanding of logs and how it relates back to the exponential expression.